Our new project will be of two parts. In the first part, we will generate some data, plot it in a single plot, then divide it into subplots and customize it a bit. In the second part, I will introduce and explain the concept of handles and how you can easily manipulate multiple aspects of your plots. We're going to generate a matrix again with our nutritional intake for the course of 14 days. So nutrients for 2 weeks is equal to, now our carbohydrates will be between 250 and 350. So round I of 250, 350, these are the limits, our minimum and maximum limits. One row, 14 columns. So we're generating vector. So this is the first row of our matrix. Our second row will be proteins, 130, 160, so round I, 130, 160, again 1 and 14. Third row will have 4 rows in total. The third is the fat and the fourth is the calories. So fat will be 50 to 80 grams, 114, and the last row will be the calories. So calories will be 1800 to 2000, 114. So this will generate our matrix. These are carbs, these are protein, fat, and calories. Let's move them a bit. So, alright. We will also need a vector for the days. The days will be again from 1 to 14, so we will create a new vector called days 1 to 14. And now, we should have probably started with this, but we can now use the size of the days for the size of the randomly generated vectors. So here we can just say size of days, like that, and replace it everywhere. So now if we change the number of days, this will be automatically reflected in our randomly generated matrix. Now, in the course so far, when we were plotting something, we were working only with vectors. Now we have a vector and a matrix, and we want to plot each of the rows of the matrix against this vector. This vector is the days vector. Well, we simply have to select each of the rows while we are plotting them. So first, we are going to use the days for the x values, and for the y values, first we're going to plot the carbs. So we're going to say nutrients for 2 weeks, and we're going to say select the first row and everything from the first row. We're going to leave it like that, and let's run it. So there we have it. We have 14 values plotted, 14 random values plotted on our plot. If we rerun it, we get different values. Every time we run it, we get different values. Now, we also want to plot the rest of the data from the matrix on that same plot. To do this, we're going to use the hold on function, and we're going to plot days, nutrients for 2 weeks, second row, and third row, nutrients 3. Alright, let's run it again, and now we get 3 different graphs on the same plot. And we can also add the calories, so it's the same thing, just we're going to use the fourth row. But we're going to get, it's now a bit scattered because the calories are much higher than carbs, the fat and the protein, and they are also in different units. The calories are in calories and the fat, carbs and proteins are in grams. So maybe it's not a really good idea to use the calories on the same plot with the rest of the nutrients. So I'm going to delete it. Now, perfect. But what if we want to look at each graph individually? Well, we can use Subplot to add an individual plot for each of our data lines. That way we can also visualize the calories by themselves. Now let me run it again. What we're going to do is we're going to split our plot into 6 subplots. We're going to have one big vertical plot on this side, and we're going to have 4 subplots here in these 4 corners. So here we're actually dividing it into 6, but we're going to use the 1, 2, 3, 4, 5, 6. So we're going to use the 1 and the 4 for our vertical plot, the one that we currently have. So we will squeeze it and we will plot each of the graphs individually on the rest of the subplots. So let's do this. So we said that this is going to be a subplot. We're going to divide it into 2 rows and 3 columns, so 2, 3, and the first subplot will occupy the first and the fourth element from that subplot, so 1 and 4 as a vector. Let's run it, and there we have it. We have our same subplot squeezed. Alright, now let's create the rest of our subplots. We need to create 4 additional subplots, 1 for each of the rows of that matrix. So subplot 2, 3, this will be on the second index, subplot 2, 3, third index. Let's just copy and paste it. So this will be 5th index, 6th index. Alright, now here we have, I'm just going to copy them from here. So here we have the carbohydrates, then we have the proteins, then we have the fat, and finally we have the calories by themselves. Now let's run this, and there we have it. As you can see, this graph is identical to this graph. Same goes for the rest of the graphs. Now they don't look to be that similar because here we have different limits on this one, but if you look at the lines and if you unsqueeze them, this is what you will get. And this is the fats, and finally the calories, which we don't have on this graph. Now we can also add baselines to each of these plots. The baselines will be the perfect value for the given nutrient, and that way we will be able to easily see how close or off we are from the values that we must aim at. So I'm going to create 4 new vectors. Carbs baseline will be equal to something. We will see what will be that something. Protein baseline. Then we have the fat baseline. And then we have calories baseline. Now, the carbohydrates baseline, let's say that our perfect value for carbohydrates per day is 300. So we need to generate a vector with 14 elements in it, and all of these elements must be 14. We can use the linspace function to do this. So linspace, our minimum and maximum values are 300 because this is the only value that we want to have, and we want to have as many values as the amount of elements in our days vector. So length days. Alright, now we are going to do the exact same thing for the rest of our baselines. We're only going to have to change the values. The proteins will be 145. This will be the ideal value for our proteins. Then we have 65 for the fats and 1900 for the calories. Now, how are we going to use these baselines? Well, it's pretty simple actually. We are going to use hold on again here, but first we must hold off our previous plot, so hold off. Then we're going to say hold on plot, and we're going to plot each of these baselines on its respective plot. So on the second subplot we have carbs, so we must plot the carbs baseline. The X will be days, the Y is carbs baseline. And then we hold off. Now let's run it and see it. There we have it. This is our carbohydrates baseline. This is the ideal value for carbohydrates. So anything that's too far from this red line here is either too much or too low. Anything that's close to the line is perfect. Now let's add the rest of the lines. Down here, hold on, plot days, this is proteins, so protein baseline. Then we have to hold off, hold on, plot days, protein baseline, hold off. And finally for the calories, actually this is not protein, this is fat, and let's just copy and paste it. This is calories baseline. Let's run it. Alright, now each of these graphs has its own baseline. As I said, this baseline represents a value that we have chosen to be our perfect value for the given something, and anything that's too far away from that baseline is either too much or too low. Anything that's close to it is just perfect. As you can see down here on the fat baseline, we have the 10th day to be exactly on our baseline. Our 3rd day is just a bit off, but our 12th day is too far off from that baseline. So this is our initial setup for the project, and in the next part of the project we will talk about handles.